Now dear students, let us discuss some questions from the West Bengal State Eligibility Test. Now in this case I have taken the 2017 Computer Science and Application question paper from West Bengal SET exam, which is also called as WBSET. Now the first question that we are discussing is from programming part. So they are saying that we have four sets: P, which is having try, not, and union; Q, which is having and, bit and complex; X, which is auto, go to, and if; and Z, which is int, void, and not. Now they are saying which of the following is correct. Number 1, element in P are C++ keywords, element in Q are C++ keywords, element in X are C keywords only but those Z are not, and elements in X and also Z are C keywords. So they are asking which of the following sets is actually containing the keyword from the C language. Now for this you should know what is the character keyword set for the C language. Actually C language is very easy because it is having the minimalistic keyword set, minimal, as compared to any other language, whether it is C++, whether it is Java, whether it is .NET or any other language. C language contains the least number of keywords, which are approximately 32. Now in case of C++, all these 32 keywords are there, but a part of this we have some extra new keywords that they have added in the C++, because C++ is just an incrementation over the C language. Now you can see in this video I have taken the keywords which are present in both C language as well as the C++ language. In both the cases these keywords exist, which are auto, break, case, char, const, continue, default, do, double, else, enum, extern, float, for, go to, if, and so on, like this. Now let us look at this set. Let us try to see what are the keywords which are existing in C plus which are not in C language. So let us try to see keywords that are not in C language. Okay, so first keyword is try. So can you see try keyword here? You can clearly see that try keyword is not there. So this keyword try is not present in C language. Now this keyword not is also not present in C language. If you can find any keyword here, then that is present in C language. Okay, as well as the keyword union, it is present in C language because union is present in here, but this try and not, these two keywords are not present in the C language. Next, in the case of Q, and keyword, you can see and keyword is not present in the C language. Bit and keyword is also not present in the C language. Complex keyword is you can see it is not present in the C language. So in set P and set Q they are not containing any keyword which is present in C language. The only keyword that they are containing is union. It is the only keyword which is present in C language. Now in case of X, this auto keyword is actually as you can see, this auto keyword is present. Go to keyword, this go to keyword here, it is also present, as well as if keyword. This if keyword is also present in the C language. So this entire set is present in the C language. Okay, in the set Z, int, void, and not. Int is present in C language, void is present in C language, but not is not present. So you can see void is here, okay, and int is here. These keywords are present. So this set X is containing all the keywords which are present in the C language. Okay, now let us look at for the C++. Obviously any keyword which is present in C++, I mean C++ contains all the C keywords which are the 32 keywords plus some extra keywords. Now you can see try keyword is present in C++, try is present in C++, and this not keyword you can clearly see here. This not keyword is not present in C++, and union is present. Why? Because union we have seen in the previous slide here that union is present but not is not at all present. In the next case we have and keyword, and this and keyword is not present in the C++, and bit and is also not present in C++, and this complex keyword, it is also not present. All these three keywords are present in C++. Int is present, void is present, and not is not present. So this X is the only set which is having, this is the only set which is having the keywords which are present in C language as well as which are present in C++, but these other sets are not having any keyword which is present. I mean they may be having some keywords which are not present in any of these languages. So the first option is saying element in P are C++ keyword, which is wrong because here we do not have the keyword not. Element in Q or C++ keyword, which is wrong. Why? Because here and, bitand and complex, none of these keywords is present in C++. Element in X or C keyword only, but those in Z are not. That is correct, because in case of Z this keyword is not present. And element in X and also in Z or C keyword, this is wrong, because here we have not keyword which is not present in C language. So the answer to this question is option number C. So I think you don't even need to remember this table. You don't even need to remember this table, because by practice after some time you'll find out that you can easily get the information. You can easily remember what are the keywords which are present and what are the keywords which are not present. Okay. The next question is from DBMS. It is saying for a DBMS to be used, it must minimally support which of the following operation and which of the following is correct. Now see, in case of DBMS, DBMS is generated using algebra, which is also called as relational algebra. Relational algebra. Now this relational algebra is having two kinds of operations. Number one, those are fundamental operations, fundamental operation, and second one, those are derived operations, which are also called as non-fundamental operation. Non-fundamental. Why we call it them as not fundamental? Because these operations can be derived from the fundamental operations only. So fundamental operations are the operations which are absolutely necessary to be in the relational algebra. So the fundamental operation is select, which is also represented like this. The next fundamental operation is project, which is represented like this. Next is Cartesian product, Cartesian product, which is represented by X. Next is union, which is represented by U. Next is set difference, which is represented by minus sign. And the last one is the rename keyword, rename, which is presented like this. In the derived form, we have the natural join. It can be derived from the fundamental operations. Natural join can be derived from the fundamental operations. The next one is the intersection. This intersection can be derived from the fundamental operations. The third one is the assignment operator. This assignment can be derived from the fundamental operations. And the fourth one here is the division or quotient operation. Division or quotient operation, and this division quotient operation is a not fundamental operation. And the fifth one is the theta join, and this theta join is also not fundamental operation, because it is just a generalized form of natural join. Now they are asking here in this question, which of the following must be minimalistically supported, or minimally it should be there. So these are the keywords which are minimally should be there. So select keyword should be there. So as you can see here, the first case select keyword is there, union keyword is there, but intersection is not minimalistic, because intersection can be derived from the fundamental operations only. Next, select should be there, union can be there, and this join can be derived from the fundamental operation. Next, select should be there, project should be there, and join it can be derived. Next, select should be there, project should be there, and union should be there. So answer is option number here, 0.4 is correct, because this is the minimal set here, and this is option number A. Option number A is correct for this. And I feel the option which is given in the official answers, because in the official answers I have seen that they have given option number C, and this option number C is actually wrong in official answers. So option answers you can get it corrected over there, but I feel the correct answer is option number A for this given question. Now in the next case they are saying they are giving 4 languages, which is language L1, L2, L3 and L4. Out of these languages we have machines. For the language L1 we have machine M1. For this language we have machine M1. For the second language we have machine M2. For third language we have machine M3, and the fourth language we have machine M4. They are saying the machines recognize the language L1, L2, L3 and L4 respectively. Which one is correct? Number 1, M1 and M2 are pushdown automatas, but M3 and M4 are not. Now here for this we can make a pushdown automata, that is correct. For this we can make a pushdown automata, that is correct. Okay, so N1 and L2 are having pushdown automatas. Now they are saying M3 and M4 are not. Now in case of L3 we cannot create a pushdown automata, so this is correct. But L4, for this L4 we can make a pushdown automata, right? So for L4 language, for this we can make a pushdown automata. So for L1, L2 and L4 pushdown automata exist, and for the language L3 this Turing machine exists. For language L3 we do not have pushdown automata. We cannot create a pushdown automata for the language L3. Option number B is saying M2 and M3 are pushdown automatas, but we can clearly see that M3 cannot be, cannot make a pushdown automata for M3. So option number A and B are wrong. Option number C is saying all M1, M2, M3, M4 are PDS, which is also wrong, because for language L2 we cannot create, language L3 we cannot create. Okay, we cannot create M3 for pushdown automata, but option number D is correct, which is saying for language L1, L2 and L4 pushdown automata does exist. Next case, consider x as an n-bit number which is the power of 2, which power k of 2. Then sum of x and x minus 1 contains j zeros where. Okay, so what does they really mean? When they are saying the power k of 2, that means whatever number this x is showing. For example, this x is an n-bit number like this. It is a n-bit number from here to here, correct? And it is a power of 2, that means it should be somewhere 2 raised to power k. Now you can clearly see, if you represent 2 raised to power 0, how you can represent this. 2 raised to power 1 can be represented how much? I mean, how you can represent all these powers of 2? Because if you represent all these powers of 2, then you can easily solve these questions. If we have total, assume 8 bits. Now 2 raised to power 0 can be represented like this, total of 8 zeros. Total of 7 zeros and 1 here. 2 raised to power 1 can be represented like this. We have total of these many zeros. This is 4 0 and yeah, something like this. So this is 4 0, right? So these are total of 8 bits. 2 raised to power 2 can be represented like this, 0 0 0 0 0 1 0 0. 2 raised to power 3 can be represented like this, 0 0 0 0 1 0 0 0. 2 raised to power 4 can be represented like this, 0 0 0 1 0 0 0 0. Okay, so whatever the power is, for example, if we have the power 4, that means we have 4 zeros. If we have the power 3, that means we have 3 zeros here. If we have the power 2, that means we have 2 zeros here. If we have the power 1, that means we have 1 0 in the right hand side here. Okay, now if I find it out, 2 raised to power k minus 1. Okay, so this is representing 2 raised to power k, and for 2 raised to power k minus 1, if I do 2 raised to power 0 minus 1, 2 raised to power 1 minus 1, 2 raised to power 2 minus 1, 2 raised to power 3 minus 1, and 2 raised to power 4 minus 1. Okay, why? Because you can clearly see here when they are giving this question. Now for this particular question, x is representing power k of 2 that they are writing. Okay, because consider x is an n-bit number which is power k of 2, and x minus 1 is actually minus 1 from this. So if this 2 raised to power k is x, so this will be x minus 1. So 2 raised to power 0 minus 1 is all 8 zeros. Okay, 2 raised to power 1 minus 1 is we have total of these many zeros, 4 and like this, correct? 2 raised to power 2 minus 1 means we have a 1 2 3 4, and we have 0 0 1 1, which is representing number 3. This is representing number 1, and this is representing number 0. 2 raised to power 3 minus 1 is 7, which is 0 0 0 0 0 1 1 1. 2 raised to power 4 minus 1 is 0 0 0 0 1 1 1 1. Okay, so this is, we have a correlation that in this particular case, whatever number of zeros we have, here we have exactly the same number of ones on the right hand side. Otherwise all the other digits are zeros. Okay, now they are saying if we have the sum of x and x minus 1, right? For example, x can be represented by any one of these. So assuming that x is like this, 0 0 0 0, there are some zeros and they have 1 0 0 0 0. Okay, so when they are saying that it is 2 raised to power k, that means here we have k zeros and all the other bits are here. So if total number of bits here, total number of bits are n, then in x will be having 2 raised to power x will be having n total n bits. So where k bits are 0, the k plus 1th bit is 1, otherwise all the other bits are zeros on the right hand side here. Okay, now in x minus 1 we have all the zeros here, all the zeros here, only these k bits are 1, only these k bits are 1. Okay, so in total if you add both this x and x minus 1, so it will be 1 1 1 1 1 1 1 up to so on, and then we have zeros. Now you answer me how many ones will be there. So these are total of k ones. Okay, these are total of k ones, and then we have one more extra one, so which is representing k plus ones are there, and rest all the bits are 0. So in total, if we have n bits, out of these n bits, these many bits are ones, then how many zeros are there? There are n minus of k plus 1, which is representing n minus k minus 1. Okay, so answer is n minus k minus 1, which is option number A, and that is the correct answer for this given question. I hope that you understood this one, and this I feel that you really enjoyed this question. I also enjoyed solving this one. Now let us look at the question number 5. They are saying consider the following tree. We have a tree here, and they are saying which one is correct. I mean, which of the following tree is actually representing a heap. Heap means root. Either root will be containing, we have two types of heap actually that I should tell you first of all. Heap, either we can have a max heap or we can have a min heap. Okay, so max heap means root always contain the maximum data. So in every subtree, root always contain the maximum data. Now here let us check the tree number 1. So in the first tree, out of all the data, this is the maximum data, that is correct. Now here also it is containing, root is containing the maximum data, that is correct. So T1 is representing a max heap. So T1 is representing a heap, max heap. In case of T2, in the entire tree, this is the maximum data, that is correct. In this entire tree, this is the maximum data, that is correct. But the problem is this is not a almost complete binary tree. Okay, so heaps are generally almost complete binary trees only. Now because this is not representing almost complete binary tree, that is why it is not a heap, even though every root node is containing the maximum data. But just because root is not containing, this tree is not a almost complete binary tree, so that is why it is not a heap. So it is not representing a heap. Now in case of T3, first of all, it is an almost complete binary tree, that is correct. Now this is following the heap property. This subtree is also following the heap property, but this subtree is also following the heap property. So all the subtrees are following the heap property, therefore this is a heap. So T3 is also representing a heap. So the only tree that is not a heap is T2. Now option number A is wrong because it is saying all the trees are heap, that is wrong. Option number B is also wrong because T2 is not a heap. Option number C is wrong because T3 is representing a heap. Option number D is correct because T1 and T3, both of them are representing the heaps. Okay, so option number 3 is correct here. I hope that you understood this one. Let us look at next one. In mixed mode arithmetic operation, an integer is converted to floating point form in the following phases of a typical compiler. Generally, what are the phases of the compiler? First of all, we have the phase which is lexical analysis. We have lexical analysis. We give a high-level language program to lexical analysis, which gives a stream of tokens. Now from this lexical analysis, we give it a syntax analyzer. Now from this syntax analyzer, we get a parse tree which we give to semantic analyzer. Semantic analyzer. From this semantic analyzer, we give intermediate code generation. Intermediate code generation. Now we give the intermediate code generation to code optimizer. And from this code optimizer, we generate the target code generation, which gives us the assembly language program. Okay. Now they are saying an integer is converted to floating point form. So an integer cannot be converted to floating point form in the lexical analysis, because here lexical analyzer is not doing any kind of conversions. So lexical analyzer is just to give us a stream of tokens, remove extra white spaces, remove comments, but it is not converting an integer to a floating point form. So this one, option number A, is actually wrong. Option number B, parsing, is also wrong, because parsing is just checking whether the program is correct or not. I mean, it will create a parse tree. It will create a parse tree, but it is not converting it. But option number C is semantic analysis. In case of semantic analysis phase only, in this phase only, we convert integer is converted to a floating point number. Only in this phase we perform some action. Otherwise, in the first two phases, we do not perform any kind of action like this. They are just checking whether the program is correct or not. So option number C is matching, and option number D is wrong, because intermediate code generation actually gives us a 3 address code. It gives a 3 address code, but it does not change it. So correct answer is option number C here. Next, 7th one. See, one more way I can tell you this one for this C option why it is also correct, because here in C option we also create something called give something called as actions. I mean, by looking at certain symbols. By looking at the grammar, what actions do we perform? Okay, you tell me the name in the comment. What kind of actions do we perform? What is called as that particular action? So just comment that in the comment section. Now the question number 7, they are saying the front end of the typical compiler is constituted of which of the following. See what are the phases of a compiler. One is lexical analyzer, the second phase is syntax analyzer, the third phase is semantic analyzer, the fourth phase is intermediate code generation, the fifth phase is code optimizer, seventh phase is target code generation, and in eighth we get assembly language program. Now option number 7 here, the first option that they are saying is that lexical analyzer, syntax and semantic analyzer phases. Now lexical, syntax and semantic, they are correct. These are the first 3 phases. Next they are saying lexical, semantic and code generation. Here this is wrong because before semantic we have syntax analyzer and before code generation we have intermediate code so this is correct, but before semantic analyzer we have syntax analyzer, so they missed one step here, so this is wrong. Option number C is likely wrong because intermediate code generation is not in the first phase. Intermediate code generation comes here, which is very later. And option D is saying syntax, semantic and code optimizer. This is also wrong because they missed lexical analyzer and they missed intermediate code generation also. So correct answer is option number A. Question number 8 is saying the limitation of Banker's algorithm resources distribution are as follows. Option number A, it can handle more than 2 processes. Option number B, number of resources are static. Option number C, number of processes are static. And option D, both B and C. So let us read out something about Banker's algorithm. Where do we use Banker's algorithm actually? We use Banker's algorithm in operating system. In operating system for resource allocation to see whether we are in the safe state or not. Okay. Now I've written some text here for all of you. They are saying the Banker's algorithm has limitations when implemented. Specifically, it needs to know how much of each process could possibly request. What is the maximum number of resources can a process request? Number 2, in most systems this information is unavailable, making it impossible to implement the Banker's algorithm because they do not know. The biggest limitation is it should know what is the maximum number of resources a process can request. Okay, and making it impossible to implement the Banker's algorithm. Also, it is unrealistic to assume that number of processes is static. So number of processes, they are saying is static, it is unrealistic. Okay, since in most systems the number of processes varies dynamically, moreover the requirements of that process will eventually release all its resources when the process terminates is sufficient for the correctness of the algorithm. However, it is not sufficient for practical system. Waiting for hours, even days for resource to be released is usually not acceptable. So number of processes are static. This is a limitation of Banker's algorithm. Number of resources are static. This is also limitation. It can handle more than 2 processes, that is correct. But these 2 are the limitations. So both B and C is the correct answer. That is option number D is the correct answer for question number 8. The question number 9 is saying parallelism is related to which of the following. See, we implement parallelism in pipelining so that we can complete more work in less time. So you can also always take an example of Henry Ford, and you can always take example of parallelism in computer architecture organization because it improves the performance of the entire system. Next, for multiprocessor system and vector system, parallelism is involved. How? I've written a small text here. Multiprocessor system is the use of 2 or more central processing units with a single computer system, right? So we have more than one CPUs, and when we give parallelism, we can give for any program we can give multiple instructions, and we can give the instructions which are not dependent on each other to these 2 processors, and they can execute and we can get the work done parallelly and in much faster pace. So this multiprocessor system actually uses parallelism, as well as this vector computer also uses parallelism. You can read here. I'm not explaining it because it is very easy and very intuitive. So correct answer for this question number 9 is option number D here. There is a correct answer because all these 3 concepts uses the mechanism of parallelism. Question number 10 is saying which of the following is not related to World Wide Web. Option number A is related because it is hypertext markup language. Web pages are written with hypertext markup language. Option number B is also correct because URL is the web address of the website. Option number C is wrong because UML is not used in www, it is something else, it is a different concept. And option number D is correct because HTTP is hypertext transfer protocol, that is also used in World Wide Web. So correct answer here is option number C because it is not related to the World Wide Web. I hope that you understood these first 10 questions. In the next video we will discuss the next 10 questions of this paper, and I will also give you the solution of the first paper as well as the second paper as well as the third paper of West Bengal state eligibility test. A part of West Bengal state eligibility test, I'll also discuss the set exam of various other states. For example, we are going to discuss about Andhra state, Andhra Pradesh and other states also, and we'll discuss the questions from them. I hope that you enjoyed this session, and thank you so much. Let us meet you. Let us go to the next session where I'm going to discuss more questions of the same question paper. And I hope you enjoyed this session. If you like it, please comment, and thank you so much.